So just fair warning today, this class is going to be all about advanced circuits. And by advanced, we mean advanced. This is going to get pretty deep, pretty fast. So feel free to stop me and ask if you have any questions. Feel free to also use this as a reference point from which you're going to circle back. So it's definitely an interesting topic. There's a ton of cool possibility here. And this is where you can upgrade your skill into like wizard level. So this is where we're going. We're going to try and make sure that we cover these things. We're going to talk a little bit about SMD components in general, because they're all around you all the time. And we're going to just explain those for a minute. Then we're going to talk about how you design with KiCad or Eagle, two different softwares. Then we'll talk about how you can make a circuit board yourself through either milling with a PCB milling or by ordering them, which is actually really satisfying also. So that said, here's our general game plan. We're going to talk about surface mount devices or SMD devices. Then we're going to go through two types of drawing software because they're similar, but not quite the same. But I think looking at two will give the process of how you'd go from an idea into a design. Then we're going to talk about how do you make circuits. And so some of this will feel like an old reliable. You can talk about perf boards yet again, because going from a breadboard to a perf board isn't super easy. But I think that it's actually easier to go from a breadboard or a perf board to a schematic and vice versa. So we'll see how that works. Then how do you mill a board? How do you chemically etch a board? We'll sort of touch on that. It's a messy process. And then we'll talk about how do you order custom circuit boards. So that said, if we're going to go in that order, first things first, let's talk about surface mount devices. Surface mount devices are sort of the opposite of through hole. So in all the kits that we've done, through hole devices have been what we've used. Those are the ones with like a resistor with long metal leads coming off the sides. If you're talking about through hole things, those are the ones up here on the left that have got these long legs that you can bend and stick in holes and then solder them in place. So those are the through hole components that we've been looking at. And they've definitely been a part of electronics all the way from the beginning. That was the easiest way to connect things. There's even some old style electronics. If you can find electronics from the 50s or 60s, every so often you'll find one that does not have any, barely has a circuit board at all. It's just a bunch of these things wired together, which is kind of crazy. The modern stuff is much, much smaller, and we call it surface mount devices. They're placed by machines typically, although you can do it yourself, where a machine can pick them up, set them on a circuit board, and then like passing through a solder bath, they can all be soldered in place in one shot. It's how you get the sort of circuits that are inside of an iPhone or inside of a laptop. Those circuits are all SMD components, maybe with a handful of hand soldered things, but almost always they're completely surface mount. These components are also cheaper and smaller. Like I've got right here a little baggie of SMD resistors. And so these are 330 ohm resistors. And if you've played with those in the space, these are the exact same specification, 330 ohm resistors with a 1/4 watt and 1% accuracy value. And look at the size of those. I know you can't see this hardly at all, but it is very, very small. And so they're 12 by 6 or 1. Well, yeah, we'll get into sizes for those in a bit. But they're very small and they come in much cheaper. Now you can solder these very small things a couple of ways. You can hand solder them, and there's a video that's in here where you could actually watch someone give you the tips and tricks on how you hand solder. But if you've been playing along and you've played with flux and you've played with solder, the next level for that is a thing called solder paste, which is basically flux and little teeny spheres of solder suspended inside of that flux. And so you can even see sort of the little spheres down here in this slide, in this image, and those will all melt. The flux is right there, and it'll wick right onto the component's legs. So solder paste is a really neat way to connect components. And what's really cool about it is that when it heats up on its own, especially in a reflow oven, we have one of those in MakeHaven, it will melt and pull the components into the right place. It's almost magic to watch it happen. There's definitely some reflow videos that are very satisfying because you all these whopper jaw pieces sort of laid onto the board the best you could do with tweezers and a shaky hand. And then all of a sudden the solder paste melts and they just zoop right into position. It's a really fascinating thing. You can do that with the reflow oven like we have right here, where you'd put solder paste onto boards, you'd put components into the solder paste and it would melt them for you by hand. This is definitely conceptually, like getting ready to do that is a more complicated task. Oh yeah, it's a good question. Why don't we use solder paste for everything? It's harder to control. And so lots of the time when you're getting started, solder paste like that is sort of goopy. Think of it more like syrup that you put down onto something. And so that syrup isn't going to sit nicely. It's not going to go where you want it to go. Having solder on a string or in a wire sort of format is easier to put where you'd like to put it. So a lot of the time it's just easier for large components for through-hole things. But when you get smaller and when you get to reflow, it actually becomes easier to solder, but there's way more prep work in order to get there. So there's a whole set of steps that it would take to do that. Surface mount soldering, I would say, is definitely a skill that's worth exploring 100%, but you want to make sure that you are already good with circuits and you have a good sense of where you want to go with a circuit in order to make that happen. Parts as small as these ones that I'm holding here, you can definitely solder by hand. And I know that they're small, but they're 12 by 6. I think that I put 12 thousandths by 6 thousandths. I think it might be hundredths, 12 hundredths by 6 hundredths of an inch. Because now that I'm looking at it, that seems way too small. And so those are definitely solderable by hand, but I've soldered by hand much smaller than that, maybe 603 and smaller sizes. So you can definitely solder by hand smaller than that, but it varies based on how steady your hands are and all those sorts of things. Here are 3 videos that I would solidly recommend, and I'm gonna let this one play without any audio. This lady, Laura Hughes, does a great job of sort of showing what solder paste is. And so here she's going to actually heat it up on a skillet, sort of like you'd make pancakes, which is a completely legitimate way to heat up your solder paste. Solder paste also has a shelf life. It's probably another good reason why we don't use it at MakeHaven. You buy it and it goes bad after a while. But she's going to show it like coming out of this little needle. I'm going to make this nice and full screen so you can see this last little bit. Here she's going to show how you'd put it onto the board. So she's going to wash it, clean the board, and then just sort of goop on a little bit of solder paste just like this. So that is a really neat, and then my internet paused. So it's a really neat technique to try and get solder onto a surface. It's sort of a goopy material that you can stick your components into, and then you'd use a soldering iron to heat that up and it will melt into place. Or if it's a surface mount component, you heat the whole board and that will melt and all of those things fall right into their position. So there's a ton of good videos. There's a bunch of different ways to do this. We have hot air station and an oven and a reflow oven, both at MakeHaven. So if you wanted to try this, what would be really useful for that is to buy a surface mount soldering kit and you can just play with the oven. We have solder paste here. It does, so the boards are specifically fiberglass so that the boards are not going to melt on you. And the plastic that's there is a special, like the green and the white is a special high temperature set stuff so that doesn't melt either. Almost every board is designed in that way so that it's capable of surface mount soldering. So because they want to be able to handle all of the heat from just soldering in general, so they have to be hot enough they can do this. The ovens take it up to the very lowest temperature that will melt at, and then they basically bring it back down nice and slowly from there. So they do a good job of keeping from burning the board. The pancake skillet that the lady had, I bought one that was dedicated just for this purpose, and it does do a pretty bad job of making them nice and toasty on the bottom. Whereas the reflow oven manages that heat curve, and you don't get the like toasted marshmallow look on the bottom of your circuit board. So the reflow oven is much better at that. Also, that is never for pancakes. Once you've used a pancake skillet for surface mount soldering, it doesn't matter if it's unleaded solder, never ever again for any food. But These 3 videos would solidly recommend you watch them. They're each good in their own right, and they've all got good tips. This is, let's see if Colin's lab, we can pull up this scene really quickly, where he does a lot of soldering by hand in this video, and so you can watch him sort of go through the process of holding it with tweezers, moving an iron in, using things to get all these pieces aligned. It may look tedious and small, but it's not too bad. It's sort of a Zen moment if you can get into that, if you like soldering as a calming project. Some people do, some people really don't. They think it's stressful. And so if you think it's a calming way to put things together, you can absolutely make this work. And a microscope totally helps, like the one that we have. So it's really cool to see all of that work. And we're just gonna keep on going. So how do you like, it's worth it to buy a kit on Amazon for maybe $10 and just try surface mount solder. We have solder paste, it's worth doing. But let's imagine that you're past that point and you want to draw and design your own circuit. If that's the case, then you can do, there's a loud beeping if you can't hear it. There's circuit drawing software. So we're going to talk about KiCad and Eagle. These are 2 of a fairly wide field. Like, we're not going to talk about Altium or a couple others, but KiCad and Eagle are good starters. All of these basically are just helping you draw lines so that you can draw your circuit pieces together. So first up, we're going to talk about KiCad. It's open source. It's been gaining in popularity, and this is essentially a circuit drawing software. And so I have this installed in lots of my computers. I'm not actually sure if it's on this laptop, but it helps you go from an idea, and many of you have seen me scratch out different circuit diagrams and put circuits together this way, but it helps you draw a schematic like this one down here at the bottom and turn it into a real plan for what connections you want your circuit pieces to have. And so you'll use a program like KiCad to make that drawing process work. And in a broad sense, there are 5 steps to make a circuit design. And the first is to place your circuit elements, the things that you want. So like resistors and LEDs, maybe an Arduino board, those sorts of pieces. Then in KiCad does it a little bit differently. You place representative symbols first, then you choose what real parts you want to make that from. Then you convert to the board, then you design your traces, and then you export the whole thing. So it's like its own process that's interesting to follow. But it's a totally free software, so it's very low commitment to like download it, play around, draw a really simple circuit, just to like have played with that software. So the first things that you'd want to do is download KiCad, and then when you open it up, you'll make a new schematic and you get something that looks like this with these red borders around the sides. And the very first thing you'll have to do is draw in circuits. And so circuits are something that we could have had an entire year-long class on just circuits, guys. Don't feel bad at all if you're unsure about where and how to do circuits. My sincere suggestion, if you wanted to try this, would be to find one circuit that you like a very nice, simple, small circuit, and you could try and come in and draw it in KiCad. Even just drawing the schematic is a great place to start, because it is easily as deep of a software as Fusion 360 is, just in its own whole weird way. So this symbol right here is how you'd add in more components to your drawing. The green lines are how you draw the linkages or nets or wires in your circuit diagram. And so those are drawing the connections that you want. So over here, I've got all these LEDs, and this is ATtiny 44. And so those are the connections to the pins of the ATtiny 44. So I've got 11 LEDs hooked up to this particular chip. So this very tiny version of an Arduino. I think Legato was playing with was it the 44 you were playing with earlier? The 84. The 44 has actually got more pins than the 84, which is weird, I think. Yeah, it's weird. I don't understand their numbering scheme, but that's what we got. And so in here, I've got just a few pieces, and drawing this is got its own whole set of nuance. But it informs everything. So KiCad does a really nice job of putting the schematic up front, because when you draw your schematic, that's really, whether you're copying it from somewhere else or drawing it all your own, that's where you lay down all of the important information about what connects to what in the circuit. So a schematic like this is really essential for getting your idea locked down so that you can design from that core concept. The rest of all of the tool chain is just trying to lock down the details of how do you make this schematic work. So your first and foremost thing in KiCad, and probably the best reason to use it, my favorite part about KiCad is that the schematic is the most important thing, and it comes up very first. So you draw a schematic like this in KiCad, and then once you do that, this is a terrible screen to look at. The user interface is almost never a goal here. But on this, here's a list of all of the things that are in that particular design. So here's all 27 components listed out, like the AT 44. Here's 11 resistors. Here's 11 LEDs, a couple mounting holes, and then a connector. That's all I've got in this is 11 LEDs with resistors, an AT Tiny, a couple mounting holes, and a connector. So once I could click on these, I can start to choose what do I want it to be? Do I want a battery? Do I want a connector? Do I want all these different things? And then right now I have battery highlighted and I've got all these different options for battery holders. The interface is awkward and every one of these is pretty awkward, but there are tons and tons of video tutorials if you're committed to trying to figure these out. And I can definitely help you work your way through these if you wanted to build your own circuit. We're going to look at a few examples at the end that makes it sort of worth it. Now, here's what that looks like. Once you have a footprint that you like, one of the buttons that you press is to switch over to, the button is right about here. This is the schematic button. But if we go back a couple of slides, this is where the circuit board button is. So you use that button to switch back and forth. And here's that schematic. We chose footprints for all of these parts. These are the LEDs across the bottom. These are the resistors right above them. Each LED needs a resistor. And you can see they're sort of aligned with white rat's nest lines. Those depict the connections that should be there from the schematic, but aren't drawn in yet. And so when you import all your parts, you might need to move them around a little bit, but this is sort of what you're looking at. And I can add in text. You've got a text tool and some of those things over here. But this is laying down the AT Tiny 44 and all of the resistors and LEDs. And then here's that connector. So all of those pieces put together. Once you have that, you can use this. Whoops, let's go back a little bit. You can use this tool. Let's see, the tool is over here. It's one of these guys. I think it's this one. And from there, you can draw in where you want all those traces to be. So you'll sort of click on one end where those rat's nest lines are, and you'll start drawing your way. Like I could click right here and start drawing my way down over to there. Circuits have an odd habit of not using right angles. It turns out you get better circuit working. They work better if there aren't right angles in those circuits. And so you get a lot of diagonals and not full 90-degree bends. It's an interesting facet. And if you're trying to draw circuits, the neat thing about these softwares is that they solve a lot of that for you. Like I didn't have to manually draw those steps. They just sort of pop in as you're dragging from one place to the other. And so I can certainly, if we have a little bit of time at the end, pull that up and show you. But you'll click through and you make this and you can draw in your designs. From there, circuit design has been a thing that was done on a computer for a long time. Because if you think about the Venn diagram that overlaps who would build electronics and who would write a program to help them build electronics, there's a lot of overlap in that Venn diagram. So this software has been around for a long time. And as an artifact of that, they still call taking this geometry and exporting it as plotting it, because it was for old designs on plotter machines that would plot out, they'd like move a pen around and plot out where to draw, or in this case, where to cut or where to print. And so in order to export, you'd use this weird, like large format printer looking button, because that's what they originally were designing for. And you'd plot out these modes or these models into Gerber files. It's a tricky thing. But from there, you get Gerber file designs. And so they're called Gerber files. And from there, we'll be able to see what you can do with them. Now we're going to rush through Eagle. We're not going to spend nearly as much time talking about Eagle, but it's another one that is a short walk from KiCad. If you want to design circuits, you're probably going to use KiCad or Eagle. I am more familiar with Eagle, but trying to convert over to KiCad. because it's open source and I want to get behind that. So Eagle is an Autodesk product at this point. It used to be CADsoft, its own thing, sort of. Autodesk bought it because SolidWorks has a similar thing. And so in the Autodesk SolidWorks war, Autodesk bought themselves Eagle, which is really cool. It actually integrates with Fusion 360. And for a brief period of time, you could draw whole circuit schematics inside of Fusion 360. I think they took that feature out since I saw it in there. But Autodesk is all Eagle. And basically, it's a very similar process. This is the software that I used to design the Arduino shields. So we're going to look at the exact model for the Arduino shields. We're going to see sort of how that came to pass, all within Autodesk Eagle. But it follows a lot of the same format. The one difference is that you start off by choosing the components you want to work with, and then you draw the schematic from the specific thing, the specific parts you want to buy and use. It's a very slight variation on the same story. But you'll eventually get to a board down here. The red and the blue, the red is for the top of the board, the blue is for the bottom of the board, and then we'll go from there. So if you're in Eagle, the first thing you have to do is grab the parts that you want and lay those down. So if I wanted to draw an Arduino shield, just like we did, you have to click on this symbol. It looks similar to what it does in KiCad. But then you need to choose exactly what you're trying to build. So here's a set of libraries. The libraries are a bit more cumbersome in Eagle, but they have been around a little bit longer than KiCad. So, you know, it's tricky either way. But in here, I chose the Arduino Uno, and you get a schematic and a linked footprint. Instead of in KiCad, you have to sort of manually link these two. In Eagle, they come pre-connected. So it's interesting to see that as they play in. Then once you put that in, like here's the RGB LEDs symbol, and here's some resistors. Then you draw in your nets or your wires or connections with this green line. And then you can also do labels. So one of the things that works in both is that you can put in labels instead of having wires that go everywhere all over things in a complicated mess. Every wire has a name in Eagle and KiCad. So you can put a label like 5 volts on a wire, and then it would be connected to all the other wires with the name 5 volts. Putting a label on them is pretty much essential at that point so that you can keep that all connected. And then you can see down across the bottom, I've got D9, D10, and D11, trying to keep track of what Arduino pin these are going to connect to. So you can absolutely use labels to your advantage and schematics and all of these things if you're trying to draw out your circuits. Then there's this switch between schematic and board button in Eagle that does basically the same thing as those buttons in KiCad. It takes all of those components and it plops them down in board format. You can see the lines here are yellow. Those are rat's nest lines that again show the links that are in schematics where they could turn into wires. And from here, you can get those linkages where you just draw them in. Also, it's worth noting that over here, here's the Fusion 360 button. You can link this back and forth. The neat part about using Eagle and Fusion 360 is that in Fusion 360, if you say I have this much of an area for a board to fit in, you can say that area is going to be a board and then export that shape into Eagle. And then that's your board shape in Eagle that you have to play with. Or exactly vice versa. You can say I designed this cool circuit board. Now I need an enclosure. You can export the 3D geometry of your circuit from Eagle into Fusion 360 and then build a perfect housing for that circuit so that you perfectly match. Like if you wanted to put a heat sink on top of capacitors, if you have 3D models of those capacitors in your design, you can actually match it perfectly. So there's some really cool benefits you get from that. Fusion 360 was even working on simulations that would tell you how much heat you generate from different components in the circuit, which is a fascinating thing. But this is its own whole step, just going back and forth. Usually they don't plop in a nice format like this. You'll need to grab them by these little yellow pluses and drag them around until you get to an arrangement that you like. There's some logic to the arranging here, but it's also sort of like trial and error. So there's trial and error in getting your circuits to work, which sounds like it shouldn't be true. But even if you try, there's some automated parts of these softwares, and if you watch them work, like you can automatically have it try and draw the wires for you, called auto trace. Even when it does that in software, it's trial and error 1,000 times. It's not like it's a magical mystery behind the scenes. It's just manually, the computer's manually trying every possible arrangement that it can until it gets one that works. So the next thing that you do is you use this tool and you can draw on your wires. You can draw on wires on the top and on the bottom. You click on this little drop down. You can choose whether you're looking at top or bottom board wires. And if you have your Arduino shield nearby, you flip it over, you'll see that these traces are there, some of them on the top, some of them on the bottom. And they give you links. The blue and red on the outside, those are actually ground planes, so that you can have, if you have a common piece like ground or maybe power, you can make it possible for a pin like this that doesn't have any wires coming off of it, that it'll just attach to the ground plane area and then it becomes grounded. So there's some neat tricks that you can do in there also. This has also got a ground plane connection where you can do that. Ground planes are also really helpful if you're building, you know, high fidelity radios from scratch, which may not be a common thing that we're doing here. You probably should not build an emergency radio for foundations class, but if you wanted to, you may need to think more about ground planes because they can help fight interference also. So there's some details in there. Then, sort of like in KiCad, there's an export feature. Instead of plot, this is called the CAM processor. It looks like a little factory, which is kind of a cute button that says, I would like to make this board, please. And so you get a CAM processor like this one over here, where you can go through and check in on your Gerber files to see what's drilled, what's the bill of materials, what do you need to buy, and what are all of these different layers. So you can choose the top, the pads are all the places where you'd solder to, the vias are through holes. You can see sort of the ground plane connections like this show up and they give some extra detail, but you process that job. And once you've got a design, now we can talk about how do you make things. So just for some perspective, we're still going to talk about perf board, then we're going to kind of work our way through the more advanced building that you can do. So breadboards and perf boards, just because we love them so much. Breadboards on the left are great. I really enjoy testing a circuit with a breadboard. It's a good way to connect some things. But when you have a breadboard, I would never buy a product if it had a breadboard inside for its circuit. They're a great testing method, but it's not what you want to have a final product live on. You want to absolutely take a breadboard and use it as a way to get to something more permanent. And the very first step for that would be to move over to a perf board or one of these proto shields. They're a great way to take anything on a breadboard, solder it in place, connect it to an Arduino or to something else, and you can use that as a way to make a semi-permanent or permanent installation if you need about one of them. You don't want to have to make 15 copies of a proto board just because it would take a lot of investment. Once you start to hit that point where you're going to make 15 copies of something or 10 copies of something, that's the time to start thinking about investing the energy into designing it and then ordering a custom circuit board or making them yourself. So how would you make them yourself? This is actually a process you could do at MakeHaven. You could mill your own circuit boards in-house. This is something I was hoping to get done, but I'm sort of working through the logistics of work folding, actually, is what's got me held up on this. But designing and building my own circuit. Milled circuits are circuit boards that come from this raw circuit board material. So you buy a sheet of fiberglass with copper laid on top. It's called FR4 board. And using the design software and FlatCam, you can design and mill your own circuit board. So down here, you can see this machine is milling a circuit board. And so with that, I think it's full screen again. With this thing milling a circuit board, we're able to see it's cutting away that copper and just a little bit of the material underneath. And all of these, here's like a design right in front of its picture. Here's a milled circuit board that I'm legitimately using in a USB plug. You can do all sorts of things with milled circuit boards. This is an Arduino's brain soldered down to a milled circuit board with a double-eyed microscope. Those are lots of fun to use. Here's a milled Arduino shield and some other things. But in this space, you can mill your own circuits. This is actually, once you've got the tool chain down, this can actually be really quick. And it can let you, like, from design, once you have a design, milling it can be less than 20 minutes. So if you have a design, if you're good at Eagle and you already have strength there, then designing and creating a board this way can happen really fast. We need to work out some logistics with the Tormach to get a good vacuum bed to hold down these things, but we're working on it. So hopefully this is something, if you stay tuned, we'll be definitely doing it this summer, or somebody can really go after it this week if they want. But in here, it gives you an ability to play with SMD parts that otherwise are going to be really hard to access with a proto board. They're just too small for a proto board. So as we keep going, also it's worth saying that reasonable traces would be about 12 mil wide, and you should have space between your traces that are a little bit bigger, because the end mill is going to be, even the smallest end mills, they're still going to have some width. This is about as small as you could possibly get, and this was on a much higher quality machine. This is a reasonable spacing between traces that you could shoot for. This is definitely more space than is needed. It took longer to cut that than it should have. So this is what you want to go for size and spacing. But how do you do that? How do you mill a circuit board is worth asking. And there's this magical process called FlatCam. I needed to put in more steps. My apologies. I'm missing some steps there. But in FlatCam, it's its own software. So since about 2017, when this came into existence, this has become much, much easier. Those Gerber files that we exported in KiCad or Eagle, all you do is you import them into here, and from there it can take that process and it can take these designs and it can turn them into CNC G code. So if you've been playing with the Shapeoko, think about designing something for the Shapeoko in a complex shape and then using easel to make the G code that works with it. FlatCam is very much doing that, just on a super tiny scale. And so this is going to make G code from a Gerber file. So GBR is typically the file extension for a Gerber file. You import it into FlatCam, and then you can say that you'd like to select the one you have. You can generate shapes and designs that go right along the edges. So you can see here the red is where the tool is going to follow the edge of those copper traces. And then once you do that, that's the isolation CNC toolpath. And so those are vectors that it's drawn, that FlatCam has drawn, that would get turned into G code very soon thereafter. So the blue lines show sort of the width of the tool and how much is going to get cut away. And I like this. This is a good cutaway. This is a good amount for the design that I've got. I actually have components for this particular design. This is my target. When we get the CNC to work, when we get to cut this in MakeHaven, this is what I want to actually make. It's just a little blinky thing. So from there, you can select that CNC geometry and export G code directly from FlatCam. So FlatCam, in just a couple of steps, will go from a Gerber file from either of those softwares, KiCad or Eagle, and it will let you mill it. Here it is in an NC viewer in a G code viewer software. So this is just like you would preview on the Shapeoko or on the Gerber. You can preview that G code, and it's very small. Don't get me wrong, but it is completely G code that could be run by any of those machines. So as long as your CNC has enough accuracy, precision, and low runout, you can mill a circuit board on any of the CNCs that we have. And I think the Tormach is going to be the best candidate because it's got the rigidity that we need. So it's definitely a neat way to make a circuit board. And like I said, this can end up being, because you're not talking about a large area that you're ever cutting for a circuit. This can be a process that takes about 20 minutes to cut, and then you're done. And then you solder on all your pieces. And if you have a big burning idea that you need to test out, you can imagine someone who's really passionate and knows all the details of these softwares can go from an idea in the early afternoon to having a cut and soldered circuit board by the time they're ready for dinner. So it's definitely something that can happen over a period of just a couple of hours, which makes this a really neat way to make circuits. It also involves a lot of processes in the shop, so there's lots of pieces to think about there. If you were to take foundations of fabrication, this process is going to be something that you'll do basically every other week, which is why I feel fairly comfortable with it. I'm just trying to get the tooling up here at MakeHaven. So if you're ever interested in this, it's definitely something I'm going to make happen over the summer, but it may, because we need to build up the right work holding for it, it may take until then. You're certainly welcome to try and beat me to it though. Okay, So if it's still, and my point is, it's still newish at MakeHaven. I've heard, allegedly, people have actually done this here. I've tried on the laser and on the Shipoko. The Gerber wasn't up the last time I was trying this. The Shipoko has a little bit too much run out. It wobbles too much. Not a lot, but just a little bit too much for a circuit board. And so maybe the Gerber could do it, and the Tormach definitely could do it. So as we keep going, this will be a neat one to see happen. You need very tiny end mills. And so I have little pointed end mills that are 0.1 millimeters in width, which is really small at their tips. Another way to build circuits is through chemically etched circuits. And this is a really classic like college chemistry process where you use an inkjet printer, you sort of transfer, you print onto like a transparency sheet, and this is why it's an older process. You print onto a transparency sheet. Those are hard to find anymore. And so then you can transfer your inkjet ink onto the piece of FR4 copper board, remove the transparency, and that ink protects some of the copper. Then you use ferric chloride to remove all the copper you don't want, and then you scrub off all of that ink. Right, and so Ada asked the question, this is like a larger version of the commercial process. 100%. This is a big, messy, large version of the commercial process. It's absolutely identical. It's just much harder to hit the resolutions that they're able to hit. And so the next, we're not going to actually go too much into this. I think we have ferric chloride in the space. So if you wanted to try this, you totally could. It's also an interesting way to get intricate designs on a translucent fiberglass material. Right, yeah, yes. The professional mode is similar in spirit to this, but there's many, many differences. There's some good videos. I think JLC PCB put out a promotional video where they like walk you through every step and show you the board at each part of the process, which is cool, but it's like an hour of promotional video, so decide how much you want to watch it. But the one that I'm really excited about, this is a cool way to make circuit boards, and I've definitely done this more as I've gotten further along in designing circuits, is outsourcing circuit boards. So this is like a little stack of them that I have taped together. But you can outsource circuit boards for much cheaper than you might imagine, like $20 to get a custom-made circuit board on the other side of the planet that is then shipped to you in less than a week. It's kind of nonsense how cheap it is. And there's many different services that you can use. But this is what I did for the boards that we made, except this, I think I hadn't selected lead-free, which I totally did for the ones that we had shipped here. But like $2 for the boards themselves and $15.80 in shipping is a crazy low price. It feels like to order a custom part always feels like it should be very, very expensive. But in the case of ordering circuit boards, it's definitely gotten to an unbelievably low price that's totally worth exploring. And so to that end, in one of my designs, I even drew in a martini glass because I just wanted to see if that could work. PCB art has become a thing because this has hit such a cheap price point. And so we're going to look at some of that in just a minute. But basically, you've got this process where you can choose all sorts of configurations from your Gerber files. And all you do is upload Gerber files to these services. And then a week later, you get a perfectly made board with all of the features that you'd want from a professional circuit board. And so because it's become so cheap, I love this slide. This is PCB art. So this is the sort of thing that when you hit this price point, people are able to tinker with it and play with it, because the production quality at those fab houses is unbelievable. So you can design your own vectors, because initially it's the same like plotter printers that you would make for blueprints. You have almost no restrictions in the designs that you make and submit. So over here is two cats as pharaohs. Those are kind of fun. An owl, a dog for OHS Park or OSH Park. This little Lego guy, he would be flat. He's not three-dimensional, but these are all the components that get soldered onto him. He is a functioning Arduino, by the way. There's this Hackaday badge. This is at a conference. They pass these out. There's two little holes to solder LEDs in. These toasters are circuit boards. These are conference badges, these squids. Those are for at some conference, those are badges, and you'd pop a battery in the back, those eyes would light up. There's a little Arduino chip down here, and on these bottom tentacles, you'd actually like network with other people by sticking the tentacles together, and they would like send, I don't know what exactly they sent back and forth, but the Hackaday article talked about how they would send information back and forth. There's even an entire article from Hackaday about how you would do this and how you'd order these. So it comes down to that. You can watch there. Here's like, this is what you should start with schematics inside of KiCad. But down here, and that's all that this little guy is this. They're putting the A in Steam. I love that. But in here, they go through instructions on how you do this, how do you set up your layers in Eagle, and sort of like you can see this would be the silk screen, the outline, put no copper in these areas, put bare copper in these areas, and you'd get sort of a design that looks like this. And all they've got is a battery on the back, a couple of LEDs, and a resistor. That's literally all it is. And then here's the circuit board coming out and looking really, really good. So it's a neat way to express yourself with very high precision. It's higher precision than we could make very easily here to be able to outsource this to a high-end manufacturer. There's even lots of different circuit board designs that get passed around as Gerber files online. So like those little toasters, you can download their design right here, the little 8-bit toaster PCBs, and order them from OHS Park also, which is just another company that you can order from. So push pins and lead-free solder, all these different things to try and design these or take this design and order it for yourself. So you just upload this Gerber file and you can absolutely order some of these for yourself if you're interested. It's a good marketing ploy to get people to like get used to ordering circuit boards from them. But I love this. If somebody wanted to build some circuit board art, the best place to start for this is Inkscape. And then you move from Inkscape into one of these circuit drawing softwares and you go from there. There's no reason why any circuit lines have to be straight. The squids are all curvy. And so it's a neat way to explore sort of circuits and push that boundary. It's totally a cool process. So there are tons of different fab houses that you can use to order these circuit boards from if you wanted to order. JLC PCB is the one that I have used, although I'm going to branch out pretty soon, maybe on the next circuit board project. But PCBWay, those are two Shenzhen, China, big time names. Then there's Sierra Circuits and OHS Park. Those are both based in America. OHS Park is made in America. Not actually certain for Sierra Circuits. I haven't ever used them though. They're from the Sierra Nevada mountains. And then Fine Line is a German company, and the Omex one is, I know the least about them. So essentially all you do is you upload a Gerber file and you get out all of these different options. So I always choose lead-free solder. Feels like a worthwhile upgrade to me, which is ROHS, reduction of hazardous substances. And then if you want, you can get a stencil for SMD soldering. If you're gonna SMD solder, it can be fun to do this every once in a while. It helps lay down the solder paste just fine. So if you're getting there, a stencil is a neat add-on for about $8. It's a sheet of metal that helps you lay the solder paste down in just the right spots. But the whole process is, again, like here we're talking under $20 to order circuit boards. This is with lead. Without lead, it's more like 25 to 30. Or without lead, it's 25 to 30. With lead, it's 20. Would totally recommend the $5 to $10 upgrade though. But we just went through a whole lot. There are many nuances to what we covered in all of this. And I don't want anyone to feel pressured to have to do this in any way. But I wanted to also make sure that you know that it's available, that it's a thing that is totally done, that can be done by people, that you can do. I'm confident that you can do it. You could build a circuit board that looks a lot like that little dog one that's got a really simple circuit, or you can build really complicated ones. I've got all sorts of examples. Here's a more complicated one that I have. Let's jump over to the wildcard week. And I'll stop sharing my screen in a minute. But I've got some circuit board examples here that are really interesting and worth looking at. So they can come in, you can design whatever you want. I've got a bunch of them to look at. And the big thing that I want to say before we end with these notes, before I stop presenting, is that in this wildcard week, if you want to go after circuits, I'm 100% here to help. but you should absolutely go after whatever it is you think you need to do. If you need more time on another project, you want a little bit of time to bring together your website, you can totally do that. Our next week is Bio Week, which I'm very excited about. I'm collaborating already with the two community bio room facilitators to try and get our gel electrophoresis stuff all set up, ordered, and make sure that we're ready to go for that. We're hopefully going to have guest lecturers for that also. And so in next week, we'll be doing community bio stuff. In this week, if you want to do circuits, that's great. If you want to do anything else, that is also great. So there's tons of opportunity there. This is certainly the PCB stuff that we looked at today is a more advanced skill, but definitely worth exploring if you have the interest and the aptitude. But I feel like I've already drug us through lots of circuit things, and I don't want to make you all have to do this. So those are the notes for today. I want to pop off of the share and start to talk. And I know we're a little bit short, but I've got some examples here, and I'd like to take any questions that we've got. Let me do this. And while the screen is still really big, or while it's relatively big, here's it's upside down. Here's one of the circuit boards that I've designed. So this was designed by me, and it looks relatively complicated, but it's essentially the same thing 12 times, where you've got little motor controllers all going through. Here's another example of a circuit board that I've designed for a little motor. This is a motor that would pump liquid around. And so it's got a circuit board that controls that motor. And I, for some reason, thought that it would be neat to have that mounted right next to the motor in this particular version of the design. So I used Fusion 360 to collect in the geometry of this pump mount, this like black piece right here, and then used it to design the shape of this circuit board to fit around that motor to not extrude too far out there. I drew in this line where that mount ended, and then I could put in just a couple of through-hole components. This is a totally through-hole board with no surface mount on it that I ordered custom made. And because it was, $25, $30, it wasn't that big of a commitment. I think on these even, I went for the slowest possible shipping. DHL 1580 was the high end of shipping. So the lowest end shipping, I think these took maybe a month to get here, but it was like $8 shipping. So worth it in the end. And so here you can build all sorts of different circuits. And then I've got other ones. This is for on top of a Raspberry Pi. And it would just sit right on top of the Raspberry Pi. It's got these header mounts, and basically it let me break out some connectors right here and right here, over here some more, so that I could get a Raspberry Pi to be connected to the circuits that I wanted. This is not a particularly complicated circuit. It's just like wires connecting from here to here. And it made my life much, much easier on the soldering and putting together end, because I didn't have to cross wires over. I didn't have to do a lot of different things. I basically could use a ribbon cable and just solder it right in to these strips, or I could put female mount headers onto these pins and just sit it right on top of the Raspberry Pi in a way that was very removable. So like I actually have a Raspberry Pi in arm's reach. The Raspberry Pi has these pins right down here. And so those pins could just get mounted. I could mount these like right onto those pins. So it would just sit on top of the Raspberry Pi like a teeny tiny little hat, and give me the ability to use those pins for whatever project I was working on. So those are the sorts of things that I think are really useful for circuit boards, that you can get all sorts of different details to make those things work together. It's really satisfying to make that work. And they get produced at a obscenely high quality, right? It's professionally made in a professional facility. The reason why this is so cheap is fundamentally because they're hoping that they're the prototypes that you are then going to order 10,000 of, right? They want it to be something that's very accessible to get a small number, because if you're a small business owner trying to prototype a design, you might need to do that 50 times to get it exactly right. But then when you get it exactly right, you put in an order for 100,000 of them. That's a giant payday for the company that makes these. So it's totally worth it for them to make this easy to upload, to have good customer service. All of that model is all based around this working. And so it's true that they're relatively cheap, whether it's from China or whether it's from the American made companies. But in either case, it's an interesting way to explore this level of making if you want to control how your electrons move. So that said, I feel like those are some of the examples that I've got. I would definitely recommend that you watch some of those soldering videos that are linked there in the middle of the slides. There's a ton of good experience and examples there. But that is it. Does anybody have any initial questions, thoughts, or concerns? Kate, what's up?
I was just curious, like, if you don't like have a project you're working on or anything in mind, what is the like most basic simple circuit board that you might want to make? Or is there an example of it either you have, or I'm sure there's millions out there, but what is a really good place to start if you just want to try out designing a circuit board?
I think what you want to do is you want to find something that's completely simple and has maybe all the instructions out there. So like, for example, my AT 44 circuit would be a good one to try and make. It's just a circuit and then some LEDs. So the main controller chip and some LEDs, and that's it. Usually it's just to try and recreate something that you've already found. Don't try and design your own at the beginning. You're going to need a little bit of background in like what each part does and sort of its role in that environment, which is a very long set of discussions to have. There's a ton of great articles on SparkFun where I went from like the physicsy background knowledge to applied electronics knowledge. So you can totally read all those. And then from that spring of information, design your own circuits from scratch. But building based on ones you've seen is the right way to go. So you can use mine, or if you wanted to recreate exactly that like dog badge from Hackaday, it's a great one to look at too, because it's just like an LED and a battery, and that's all it is. So start there just to play with these softwares to get your foot in the door.
Corey, are we gonna circle back around to this, or is this sort of like an open, like you said, it's a wild card week, but will we come back to this or no?
So it is a wild card week because it gets really deep really fast. And so the reason for that is like, and that's why it's a wild card week. I don't want it can be something where if you have a strong electronics background, this is super exciting. It's very liberating. Maybe you've never milled a circuit board before. It's something that can absolutely be done here. And then I'll be circling back to this because I 100% want to mill a circuit board. My intent was to try and get that up and running as a process before we got to this week. But of all the million things that have to happen, that's one that just didn't. And I want to own that very clearly. I intended to get that done before we got to this week, but it just didn't happen. And so I can't say like, here's a design, you should walk in and we can press the button on the Tormac and watch it happen together. That would have been my ideal, but there's multiple things that we had to create. I tried in multiple different ways to get it to be that experience, but it just didn't fly this time around, for which I apologize. Over the summer, 100%, I will let everyone know in the channel, I'm milling a circuit board today, come watch. And I'll do it multiple times just so you can play along.
Sounds good to me.
It may not be, yeah, but that might be the circling back that we do. When you
guys where would be a good place for like some of us to start in terms of, because a lot of things were covered, like surface mounting, a new program for schematics. I want to do everything you talked about. I just want to know like in what order and like what's reasonable so that it,
if you're trying to go after these goals, there's sort of two things I would say to go after first. The first one would be to like go on Amazon and get a surface mount soldering kit that's less than $10, and absolutely like do not try to design it. You just want to buy a little kit that'll be blinky, and then we can surface mount solder it in the space. So that's leveling up your soldering game is one route. The next route would be doing the design work for a circuit so that you have all of that process of going through Eagle to Gerber. And then I'd say order it if you wanted to really have that at the end of the day, because then you don't have to worry about milling. And then if you want to absolutely level up your game even further, the last step I'd say would be milling your own circuit boards once you already get how the design works and ordering a circuit board. Because ordering is just you press the buy button and send them $20 and it's done.
But the
You
milling
will-
isn't quite set up yet, right? Here.
Yeah, it's the same. It's the FlatCam stuff would be the last skill that you want to develop.
The what?
The FlatCam, the design and milling a circuit board is the last one that you'd want to build up.
Okay, so we can hold off on that like until
Yeah.
everything's set up. So
Hold off on that one.
okay, so then basically order a surface mount kit and start kind of working with
Download KiCad.
KiCad, right?
Yeah.
And play with that.
Yep.
Cool.
It gets real deep real fast though. So like you need to be okay with following some instructions and just watching them click through things for a little
Okay. Do you have any recommended toots for that on YouTube? Or
while.
can
I will
we come
find
in?
some. Kate found a soldering kit that looks perfect. That's a good surface mount soldering kit for $8, less than $8.
Cool.
So
Right.
that's absolutely a winner.
And is there any way to work in like the programmer with the surface mount so I can get a twofer? Because it's been on my agenda and it's been that thing in the back of my head. And I'm wondering if anyone else
Yeah, they're easiest to do with the programmer. So yes, this is where it gets real advanced real fast.
cool.
Wait, but that is first circuit maybe shouldn't even be one that takes a program. So like just LEDs put into a circuit board.
Okay.
Yep. All right.
Oh,
There
you know,
are-
oh, never mind.
Ada,
did-
you had a question at some point. Mm-hmm. Oh. Yeah, Ada brings up a good example that like she's working on a project right now and she has a breakout board for her inputs on one side of the Arduino. So she's got an Arduino Nano and there's a breakout board she's using for capacitive touch. And then on the output side, she wants to use a couple of MOSFETs and use her outputs. And it would require some soldering and perf board. And if you wanted to, you could instead, she asked like, would it be a good example to just make the outputs half of a circuit into a breakout board, just for the sake of sort of trying it? Absolutely, that'd be a great one because the circuit's relatively simple. There's not a lot of parts. You know, for $20, you get to test, have them ship something that's really nice to you. And if it works great, then it's a perfect circuit and you just be soldering in the components and then a couple of wires and it makes the complexity of it something that you've done in software before. And then when you go to actually assemble it, it's pretty much mostly done. You're just like connecting the pieces together. Yeah. And it would probably help keep it smaller. Yeah, for sure. So you've got the benefit on multiple fronts. From it keeps it a little bit smaller. It can like offload the trickiness of thinking about the circuit beforehand and goes from there. Any other questions? Because there's a lot to this.
Can we repair surface mounted devices? Like I have, as you can see behind me, I have this strip of LEDs, which I have working, but I was a little rough with them. And there is, I think it's a resistor, something on there is broke. And when I pinch it, the light will come back on, but if it gets moved around a little bit, it goes back off. And I'm curious if if that's doable.
The short answer is yes, in theory, as long as everything still is almost ready to work. But like you can absolutely get custom circuit boards that are flexible like this, which is how those LED strips work. These are also custom designed sort of PCBs and flexible PCBs. This is going to take you on another tier for price. But when you bulk order them like these LED strip manufacturers do, then they become cheap again. So this resoldering pieces and desoldering them from a strip like this is possible, even by hand. You just need to be very delicate with it, and it would need to be the solder joint that's failing, not like the strip. If it was bent too aggressively and like the strip is starting to fall apart, then you're going to have more trouble with it. So
Okay.
it's possible, but repair is always tricky.
Yeah, it is.
Yep.
All right. Thanks, Corey.
Yeah, no problem. All right. That said, you were all molding and casting this week, and I feel like we've made it through the electronics. Let's let it sit. This is sort of weird in that we're gonna have a lecture and then we're gonna kind of not do work with it. I just wanted to make sure that you were aware that this existed. It's a space that you could explore. And I would strongly recommend at some point, but it doesn't need to be today. But I'm really excited to hear about what you did do and maybe what was interesting in the lecture from today. Like, what was the part that resonated? Did you like that PCB art? Do you think it's worth the investment for that? Or would you just like to collect some? You know, there's all sorts of things that could happen in there. So main question, what did you do this week? Give us a little show and tell, and we can see what's up. The short version for my show and tell is I did some pewter work, and here is an ingot of the pewter that was in that piece. This is just like the leftover pewter that was there. I took it out of the chamber, so that out of the melting pot, so that we could clean it out a little. This was just between some blocks of wood. This is all the pewter that was inside the bin, taken out and cooled. What? Pretty heavy. Pewter is like 7 grams. It's heavier than steel. It's more dense than steel, so it's an interesting material. Yeah, it's real heavy. So it's a fascinating thing. And we do have a full size ingot in the back, the one that Wogata and I bought last week. It's massive. For $40, it's huge. So I'm very excited to do more pewter casting. That'll be a fun one to try. So it's a neat way to go. Cool. So that's my quick show and tell, but I'd like to hear a lot more in detail about what all of you done. Would anybody like to go first? Yeah, Lila, go for it.
I'm gonna go because I was kind of lazy and I didn't cast my object. So I'm gonna use my time to ask Corey about concrete.
Ooh.
I would like to cast it in concrete, but I also looked into buying concrete, and it's like, am I gonna buy a 60-pound bag of concrete to make? Okay. And am I gonna be able to carry a 60? Like, I'm just thinking of logistics of getting this to Home Depot to my house.
No, that's a very how
Split it, Lila.
What?
I'll go half and half, Lila, if you want to split that.
Or if anyone else wants concrete,
I'll do.
Oh, the concrete is the cheap part. It's like
like $5, but I just am like, what am I gonna do with this giant bag of concrete once I have it?
There's a Lowe's right next to my house. I'll swing by and pick up a concrete on Thursday on my way in. How about that?
I would appreciate that.
Yeah, no problem.
Sounds like some concrete plans right there.
Yeah, it is, but I'm
I love it.
Good. I like that. Yeah, I'll pick up a bag and then we'll have it on Thursday and we can do.
Yeah, I feel like I don't have a lot to do. I just need to do it. And the concrete part had been on my mind, and I was gonna send you a message on Slack, but some stuff to think out. And also, is there some kind of additive I need to buy to put in the concrete as well?
Your experience will be much better if you have some plasticizer. So
okay.
I would say order the plasticizer on Amazon and it'll come in, by Thursday.
All right, I'll talk on Slack and just make sure I'm gonna order the right thing.
Yep.
And what else can I tell you? I have a rug I'm gonna make in mind I'm gonna be working on that this week.
That's so exciting.
And the last thing I was thinking, I don't know if I'm actually gonna do it, but I don't think I actually showed this. So I made this a while ago, but maybe I can make a circuit board to put this on. An idea? I don't know.
Because that's a breadboard, right?
Yeah, I tried, I don't know where it is. I think I tried soldering it at one point to this. Yeah. But the wires are really flimsy. Even right now, one just kind of fell off in my hand. So I ended up going back to the breadboard.
Yeah. No, it's worth it to think about when you're doing a proto board, to think about sort of the layout. The translation from a breadboard to a proto board isn't totally smooth, but we can look at like what connections do you want and then use wire that is the right kind of wire for what you want to connect. So
right.
the big thing for that is often I'll want to have like a hole that I'm going to solder to on both ends. And so for your like distance sensors, do they have pins on them? I'm thinking about the ultrasonic distance sensors or like
Yeah.
the eyes. Do they
Yeah.
have pins on them?
Like,
We-
I don't know if it'll really be worth it. We could think about it. I don't know. I was just kind of thinking what I could do with this.
No,
But
what's often good with those breakouts for like the eyes that you have in LED matrix is to carefully desolder the pins and then replace those with wires so that you can solder from the hole in the LED matrix all the way to the proto board, and there's no like jumpers in between.
gotcha. All
So
right.
it makes it way more robust and it won't ever fall apart on you.
All right.
Mhm.
All right. That's all. Next.
Yep. Also, that may have sounded hacky, but like main motherboards and daughter boards are used all the time in laptops. Like a laptop will have a main motherboard that doesn't go to one side, and then the USB ports on the other side are just on like a little tiny board that are connected with some wires that sort of dangle from one to the next. In a way that's way more like unsecured than you would think. So,
Do we get to
yeah.
know what you're going to cast in concrete, or is it a surprise?
Is it the planter from last
It
week?
was that planter that I had printed the 3D thing, and this week I put some like a resin goo on the inside to smooth out the layers. So yeah, we'll see. I haven't gone back to check out, and hopefully it all solidified and it's ready to go. Concrete. All right.
All right, who wants to go next? Have anybody? There's some people in. We've got
I'll
Wagata.
go too because I also really did not get to. I don't know if it had to do with my back or I just couldn't find anything to really mold. But after the table, I think that was the closest thing I came to like putting the border on the table and re epoxying the tables. But then from there, I feel like this was my wild card week because I did some textiles with Denise, and I came back yesterday and I had planned, and I can't show it to you because I'm in the city and my stuff is drying in Connecticut, but those laser printers, I laser printed on cardboard, and then I went home and I'm experimenting with like covering them or even trying to make molds of my photographs. So this was just the first stages of using cardboard to do that. I wanted to see if I could make a cardboard epoxy table. So I just did very small samples to see what the laser cutter did on that. And then I went home and took what I had, which was Flex Seal, and shook it up and just sprayed it. And I don't know what the results are because it was late at night. I let it dry. And so I'm gonna have to come back and show you folks later. I'm sorry, I don't have anything to show you, but that's what I'm kind of playing around with. They're not really traditional molds, but I do want to come back and I actually want to make a chocolate mold. So I want to use the silicone and do a proper mold. I just got into other projects this week and then didn't do it, but I figured I can circle back around and do it.
Yep, absolutely. Cool. Well, that's exciting. And it was neat to see the laser cutting. It was good to like explore. I love how much everyone's exploring like what can you do with the laser.
Yeah.
It's really cool to see like all of the different like laser cutting fabric and laser cutting paper and cardboard and all this stuff. It's really cool.
An acrylic mirror was really fun.
Oh yeah.
Yeah, it
that
was really.
Awesome. All right. Let's see. Next up, who's got something to share? Wagata looks like he's ready to go. I'm going to mute so that Oh, he's gonna come up here. Sorry, Ruby, I saw you signaling. Okay, next up.
We have enough space up here, maybe?
Probably.
Okay.
Yeah.
All right. So I worked with Julia these last few weeks, and just finished my project in a rush yesterday. So this is a second unveiling. I just peeled it back. So what I made are just a few utensils, a mold on this. And so you'll notice that there's clay put around this is just to make the parts a little more robust when they're taken out. And so I started with this last week. The bottom mold took about a day to dry. And then I did the same. I flipped it upside down. These three utensils were sitting in clay. So I turned it upside down, peeled the clay off, and then poured this shape on top of the top portion. So this, still a little sticky. So this area is where the resin will flow inside here. And all these little gaps are is what allows the air bubbles to escape as the resin is pouring inside here. So I'd like to try the epoxy resin, the pewter as well. And if I can find maybe like some sort of biomaterial that has a good flow that can kind of take up the shape of these three pieces here. So a lot of these areas were used, there was a pen that was used on the clay that got these holes here so it can not line up nicely. So I'm hoping that there's not much leaking that goes on once I get that all poured in. So yeah, that's it.
Yeah,
Thanks.
That's great.
You could make chocolate cutlery. You could.
Honestly, like a chocolate spoon, I feel like that would go over super well. Yeah. a
Put
chocolate
sparkles in the middle.
spoon, chocolate spoon for hot cocoa to like swirl it and it melts away.
Or to eat ice cream with.
Or
Jamie,
yeah,
I think that's like the most brilliant idea I've heard.
that is
I think we should do it and have a party.
100%.
We can roll.
I want to eat ice cream with a chocolate spoon.
Me too.
That's what I want out
With
of my
Bogata's
life.
chocolate spoon.
I don't know if that is food safe, but yeah, we can watch it. I've eaten worse things. Man. Yeah, that's a cool design that he's going after. There's tons, and like think about just from plastic silverware. There's a ton of potential from molds because you just get to completely copy a shape and then use it for whatever you want. And he's using, plastic and clay, and you get whatever, you could have made whatever fancy handles you wanted, which is really neat. And I think the handle, you like did etch some stuff in your handles, didn't you?
Yeah.
There's, yeah. But there's like some symbols you scratched in, I thought I saw.
Oh
Yeah, there's like numbers and things scratched in, like all sorts of cool stuff you can do to get that shape. Yeah, it's really cool. All right, Ruby, you wanna share?
Can I ask real
Excellent.
quick, what was the blue material? What
Oh, the blue material was Umu, I think it was Umu 25. Umu 25, which is in the space. Was there any left?
Yeah, there's a little bit left. There's just two big buckets
Yeah.
sitting on the bottom shelf.
There's some left, 2 buckets, bottom shelf. Yes. So there's some more of that left if you wanted to do more.
We're running out.
We're getting low on part A. We'll hopefully get some more. I was thinking about getting some high heat stuff from Smooth On. We'll see. Maybe there's some different options that we can go with. But yeah, that's totally, there's a ton of interesting potential there. But sorry, Ruby, go for it. It's your time to shine.
I had a question actually for Bogata. How stiff was that Ulu 25?
How stiff is the, yeah.
How bendy was it? Or vice versa?
Yeah, come on up and answer.
Hey, Ruby. It was really hard to get that to flow. Like I was literally using the stick the whole time to scrape all the corners and stuff for that stuff to get in there. So I did a vacuum, like a vacuum release to get all the bubbles out and stuff. I tried to pour from one corner, but it wasn't pouring too well. So there might still be a few more bubbles in there. But from what Julia was telling me, if it's like a new bucket, it should flow a bit better. So if we have a new bucket, I think, because the other one's almost out, I think it should pour a little bit better.
Cool. All right. Thank you. Hi, everybody. I had a not so great week. I really wish I could have done more. I'm kind of wish I, could have done more, but it's all right. It happens. So this week I redid my my keys. Let me share my screen. Come on. Okay. This week I redid my keys on the Shipoko, and it went super well. Corey very, very kindly allowed me to borrow his downcut eighth inch bit, and it came out really good. The Shipoko did not stop, and I'm super relieved that I didn't have any issues. And I could like, I understand a little better now the finish difference between an upcut and a downcut. And it was just nice to like actually be able to like see it and like touch it and whatever. I didn't get to fill it with resin. I want to still do that, and I want to still do that little like rubber mold of like that like rectangle shape. So I can like make some resin coasters. But I also spent some time on the laser. And I am getting closer to figuring out how to laser engrave tones onto like using to be able to engrave images that have like a good tonal range. So this is a picture that I have been playing around with, and I think the main thing for me was that all of the YouTube tutorials on this particular like thing on engraving photos tell me to use a diffused photo on Photoshop, or like it's like a way of making a bitmap. It's like a form of bitmap, I guess, where it turns your image into like tiny little dots. Like it makes up tiny dots. And I haven't tried that yet, but I think I understand why. And like the particular way that they like go about it is instead of turning it into a vector in Inkscape, they just go under file print, and the laser will only print like exactly like what you have. So I think that's how you get literal like tonal range, instead of going through the trouble to turning an image like this into a bitmap vector, because like this image was so high quality that it would crash Inkscape every time. So this isn't the diffusion. This is just me figuring out like the file print approach. And it came out like it's one tone, which is fine, but I got a lot of detail out of it just by like avoiding to turning it into a vector. I could probably even zoom in. Like it's great. And I made this piece to put into a print exchange, and unfortunately I just, after a few like they weren't coming out like to the standard that I wanted to, so I like decided against it. And instead I printed out a different image on the large format printer, and it came out great. But yeah, so this is the laser engraved image, and I'm gonna try that this week, I think, and I'm feeling pretty good about it. I think I'm so close, and it's just like one more try, and like it'll be great. Anyways, this is the image that I went with. I took a cell phone photo of me at taking a hike a few months ago, and I printed it I changed the resolution in Photoshop. It was like what 72 before, and it came out kind of pretty pixelated. I mean, it was like 22 by 28 inches, and I changed the resolution to 300, and then I printed it out, and I mean, I think it looks great. I'm super happy. I use a camera a lot in my work, but lately, my phone's super convenient, and I mean, I think this is a great. I think it's great. I didn't expect to have this much success with it, and yeah, that's about it. I'm gonna stop sharing my
Oh,
screen.
you had a picture. So a couple of things. I think it would be great. Like I'm imagining now taking that picture and turning it into like the little dots that you'd see in a comic book to give all the tonal colors. And
Yeah.
so I think that would work really well. If you could take an image in Photoshop and turn it into a series of dots
Mhm.
and then have Inkscape just cut like the perimeter of those dots to give you your color, that might
Mhm.
work. That might work well.
Yeah, I'm convinced too. My friend asked for help this weekend on the laser, so I came in and we tried it. And I don't have any pictures or anything, but we had great results too. And I'm excited to see what he does.
Oh, that's cool. Oh, also Anna had a good, Ileana had a good suggestion. If you download, is it Halide? Yeah,
Oh my God, thank you.
or you can unmute.
Holiday, I think.
Sure.
That's
so-
I
that's
didn't
really,
know you could do that.
yeah.
I don't know if it's every phone. I know iPhones, that particular app is for iPhones. I don't know if Android has something similar, but I'm pretty sure it does. I think if your phone is newer than like 2017, you can get a raw file from the cameras are high enough quality with enough megapixels that you can get a raw file pulled from the camera on your phone.
I'm so surprised that they don't just include that with their phone app.
I think
Because-
that the HEIC file type is like a modified RAW, actually, which is why lots of things won't open it.
Mhm.
It's
Yeah.
also a lot, like if you just had raw files on your phone,
Oh, it would eat it up.
you would have significantly less
Yeah.
space.
But you could take the photos, like, because when I shoot, I take them and I put them on the hard drive, and then I erase everything from the card anyway. So, yeah, but it's good they have a program. I didn't even know you could do that with the iPhone. I didn't know they were that good now, the newer ones.
Yeah,
Cool. Thanks. Good
Yeah.
tip.
sure. Thank you.
Yeah.
Ruby, that photo is like an illustration. That's what it looks like. It's like otherworldly. It's really cool.
Thank you. It's called I know this title. It's called Risen from the Grave, and it was one of my first hikes in COVID world,
Mhm.
and it was super. My life was super chaotic at the time. I like just moved, and my friend gave me this super pretty mirror, and I just I had to go outside, and yeah. I could life size. It's like pretty big.
Oh, yeah.
So
Yeah, I was there when you were printing them. They really were impressive.
Yeah.
right now it's just hanging out on my couch, but
Mhm.
okay, I'm done.
All right, cool. Also, Ruby badged me this week. It was great on the large format printer. That was lots of fun. We made a banner for
We
Carolyn for birthday.
Corey still has to take the video and pass
Oh,
the
yeah.
quiz.
Oh, no, I got to do that part. I got to, I know.
Take the quiz.
Just warm up that elbow, why don't
You
you?
caught me.
Just
You
warm it
caught
up. Yeah.
The quiz is
That
easy.
was-
All right. I'll do it. Let's see, who's next? Who would like to share? Let's see, we've got a few people who are
I can
on.
share.
Yeah, go
Um,
for it.
Okay, so I did write a blog post this week, but I don't think I'm gonna share it because I'm hoping to improve upon it during wildcard and maybe get some better results to share with you next week. So I will just share a couple of things. Let's see. I tried doing some clay mold making to do an investment mold. Air dry clay is what I had and not what you want to use. So I was trying that out. I'm not going to go forward with that. I think I'm going to do something different with the investment. I did do some glass work. I learned a lot about what not to do by trying stuff. So it actually feels like a lot of success, even though it really went badly. So I'm okay with that. And more on that soon. I also went back to the Shipoko. I got a little bit of luck here. It did not stop for me either. So I'm hoping this is a trend. Maybe the Ethernet thing did fix it, combined with the driver. So that was exciting. And then I also, let's see if this works. And then I also got the laser.
Oh man.
Yeah, okay, that's very effective. So I don't know how much you can see, but
No, that looks
It's
great.
super effective.
my horrible bendy jerk fail from a couple of weeks ago, you may recall. I went back to the laser. As you saw, I tried to poke on wood, but it seems to be working now, and it's like solid. And I'm gonna end these out back here, but it's like that was
cool.
exciting. So
That is really cool.
I'll turn those on. Oh look,
That is very
we can go blinky. That's horrible, but we can.
It's not horrible.
no, it's not horrible. Is that EL wire?
No. Yeah. So anyway, so that was successful, and I think that reminded me that you can fail splendidly and then go back, which is what I hope to do after this week.
There you go. Yeah, I feel like you can learn so much from getting something that goes wrong that it usually it's disheartening, but also in an encouraging way, which doesn't make any sense. It can be sad and frustrating, but it's usually the best road to really move forward. So awesome. It's part of the importance of play that we talked about a long time ago. And I just want to reiterate, we're playing is essentially what's going on. And don't forget that you got to brush off your knees and try again when you fall down. Just part of the game.
Not fails, they're rough drafts.
Oh yeah.
Practice. Piece of cake.
All right, we've got Ada and Ileana. Either of you, and Aaron. Those are our three that still have to go. If anybody's got anything to share.
I can go really fast. This last week, I feel like has been the opposite of creating. All of the technical things in my life have seemed to like gloriously fall apart together. I had a laptop die. The toilet light doesn't seem to be working. I have to figure out why that is. But just personal life has been kind of crazy. So unfortunately, I don't have anything to show. But sometimes I'm humbled by my creations needing more attention than I give them, and sort of like coming back and being like, how did I do this again? Like, and then if you put it on your website and could go through the documentation, you'd know how you did it the first time. So this is sort of like a humbling, like, slap across the face. So, yep.
Oh, no slap across the face, but it is a good argument for documentation. I've definitely used the documentation I've written before many times, especially when I was building a lot of circuit boards. The first time I milled a circuit board was the first time that I had to mill a circuit board for that class, the Fab Academy class. And so I wrote a ton of notes that first time because I knew I was going to do it many times again afterwards. So at different moments, it can feel really important to write up that documentation. Other times, it feels like a far off chore that like you want to put off.
Actually, I have a question for the group. I'd really be curious to have your advice. Like, so I feel like when I start a project and I start documentation, I find like a guide that I like, inevitably you sort of fall into this space where maybe the instructions aren't quite right anymore. Like, Kate, I'm thinking about about you, and early on in the class, you were talking about how a lot of the instructions that you're seeing just forgot a really important part. And eventually, like, the paths sort of diverge. And it's like, maybe you get frustrated, but inevitably, like, I get frustrated, and it's difficult to even remember what I actually did, like 60% into the project, because it diverged so deeply from my original set of instructions. So I'd be curious to know, like, how people might process or parse things out, or if you just have the discipline to be like, I'm going to put this down and pick it up later. Like, how do you guys do it?
Ooh, that is a good question.
Also, I'm sure everyone has their own process. For me, I take a ton of photos just of every step, and I end up deleting a lot of them, but I'll take them from different angles and stuff. And I also take little videos talking to myself like an idiot, like, like, oh, I did this thing and it said to do this thing, and which is basically like notes. But I've also tried really hard to try to get something every week. And there's been a couple of weeks that I missed, and I actually can really feel those the differences. I'm like, how will I get back there? I do have the photos and stuff, but it trying to get as much down as I can makes it a lot easier if I do need to go back and edit and add stuff in later when I remember it or find it or change it. Even having basically like a rough draft of a blog post has been really helpful.
Awesome. Thank you.
Yeah, I'll because a lot of the things that I make are digital in some way or another. I'll keep a lot of versions of files. So like button board 1, button board 2, button board 3, like just keeping versions so that I can see sort of sequentially where I'm at. As I increasingly have improved my skill, it does let you see past versions. So you can like wander through a project and look at how you did things in the past. That is next level use of Git though on software things. And then I do tons of photos. Like I have photos from all sorts of different projects, all sorts of different ideas, and all sorts of different scratches that I've like things that I've scratched down and written on paper, drawn noodles. Yeah, button board final, final two, eventually final. Those are never mark one final ever. Never do that. Just know what your last number is. It's much easier. The key though is to like keep track of those things. And then also, because I write a fair amount of code for projects that I work on, I try and write code in a way that has comments where I need it, and I write code so that I can go look at it and read it later, and it will make some sense, which is a game that you get better at the longer you write code. But it's definitely the mark of someone who's fantastic, and I'm not fantastic at writing code, but someone who's fantastic at doing that will write their code in a way that's deliberately readable for when they go back and look at it later.
I will say, Corey, that I've really appreciated that about your code as someone who feels like they're absolutely reading another language. Like when I look at it, I can decipher it and I can get through it. And so that's been huge.
Yeah.
I think like, excuse me, I'm trying to like transfer some of my process and coding into things that are not like, and that sort of iterative approach and being able to like get that down. Maybe I should just start writing this stuff in code. I don't know. That's an interesting point. Maybe I take the way I do it one space and use it in another.
Lots of pictures really help.
Yeah.
For me, I'm a visual creature, so a ton of those, because they're time stamped and you can like look at them in order. Google Photos does a lot of the work for me. So like I can say, oh, I know I did it on this day, or like scroll through the photos until I find one in the chain, and then search for photos of that day, and they'll show up in timestamp order. So I can like watch those things happen that way is really helpful.
Yeah,
have
and I take
conversations.
pictures of the like stupid little parts of the step. Like I'll take a picture of something when I put it into the kiln, a picture of the kiln screen, and then a picture of it coming out of the kiln. So it's like, oh, I did this firing program, or I did like not an interesting picture. It's just for me to remember which part that was. Sorry, Jimmy, go ahead.
Oh yeah, no problem. I actually get to go back and remember my process if I can't get it down on the website by sometimes having conversations with Corey I then go back to the Slack conversations and look at things I shared. I like, there's different ways I do it. Like I shared what I did with you folks in class on Instagram. So that kind of jogs my memory that it's there. And I know that doesn't sound like best way, but sometimes just talking it out is, and then having that in documentation, like the conversations I have with my instructor, helps me go back and relearn the process if I put it down, which it kind of helps reinforce it months later. So,
yep. Another thing that's worth mentioning, and this is probably not the problem that you're having, but one of the things that is worth saying is that if you're following instructions, there's a big, and this is because I teach high schoolers, if you're following instructions, you don't have to be that engaged to follow instructions. Whereas when you're generating the ideas, when you're creating those things, that's a far more cognitively complicated task. And so you're just connecting more dots inside your brain, so it's going to be more memorable. And so when you make that transition and you're like, oh, now I've done it, it can be hard to spot like where you will remember the parts where you deviated, but it will be hard to remember the pieces that came before that, where you're like following the steps 1 through 14 and then you deviate at 15. Usually like around there is where you'll start to remember it again. And all the stuff that was like procedural is just gone. It's just lost.
Interesting. Like if I understand that, and maybe I'm extrapolating a little too far. Like if I'm just following a guide, I'm not really thinking about it very much. In particular, if I'm not really grounded in the disciplines, like the making disciplines that are used within it, I may not have the same connection to it that I might if I really understood that discipline very, very broadly and could make all of these connections on how to put things together and to really be more grounded in what it was that I was doing. Is that a fair sort of rephrasing?
Yep, we try. That's a good way to ask it. And we try and use a new process called active reading, where you're like asking questions as you read and that sort of stuff to make sure that students are more engaged. It's not really new in any way. It's just like a thoughtful reader will be asking themselves questions as they go, but we give it a name and pretend like it's new so that it catches with everybody. And so if it totally depends on how you follow instructions in a tutorial, but if you follow it passively, it's not going to stick as well as if you're fully like questioning what's happening.
Great.
Which is interesting. How the brain works. It's fascinating. All right, we've got more people to talk. Let's see. There's Ada has got a thing over there, and then Ileana, you wanna? Let's see. All right, Ada is ready to go. I'll point the camera at anything you want.
Hey, so I just, like, as the last few people were sharing, was taking, my mold just finished curing. It was in the pressure pot. And I just, like, took it all apart. This is the clay that was under it. I did so this is just the first piece of the mold, and I did it very similar to what Wagata did. Except Wagata's reservoir for the castings is like on the side, and mine is actually going to be going straight through. If you see here, is that visible?
It's like blown out a little bit. If you took it this way, it sort of works better.
But so I took it off, and the clay was all under here, and this is what is supposed to be the drawer pull for my nightstand. And then these are for air vents, and then this is where I'm gonna pour the epoxy. And it comes out pretty well. And there. And so I'm gonna have to put this back in and pour the other half. But yeah, I'm pretty pleased with how it came out. And I thought that this silicone, I used the Mold Max 10. I thought that it was maybe going to be a little bit too soft, but it feels quite good actually. I'm very pleased with it. And yeah, this is exciting for me, especially because um, I do a lot of I do a lot of designing for casting for jewelry. Um, but I've never really done the molds and the castings for it. And so this is like very promising for me. I'm excited to make the molds in the future. Uh, what? Oh, this isn't. This is going to be epoxy resin. Yeah. And the you would never ever be able to cast the kinds of metals that I want to in silicone. You cast wax versions in the silicone, and then you um, do investment casting. So like you um, encase the wax in plaster, and then you burn out all the wax, and then you put the molten metal in the plaster, and then the plaster is destroyed to get the metal out. And that's the process each time. Yeah, but I mean, those metals, the metals that I use need to be like about 1400, 1500 degrees Fahrenheit to be molten. So you can't, you can't do it into silicone. So that's it.
Cool. I feel like there's very nice, some masterful casting, mold making happening here. So that's definitely not the level of mold making that I have been able to achieve. Julia is absolutely a pro. If you haven't yet gotten a chance to work with her, she is a delight. You totally should. Um, and there's all sorts of cool things that you can make. So
I have to say, I'm really enjoying the like unveiling of the mold stuff. I think that should be a regular thing with casting in plastics. And so if you're doing something and you're not going to do that in class, you should take a video of it because it's like really exciting and fun.
yeah, it's like it's better than opening a present.
It is opening a present. And if
Yeah.
anyone is doing casting in plastic, like mold making, any of those kinds of things, and you have pictures, if you could send them to me. We have very few pictures in this area, and I would love to get more pictures because it's really exciting and cool, and I'd love to get more people involved with it.
It is. And then also, I think the metal casting is really neat. I played around. I gotta dig for it in my bag, but that's what I was trying to do a little bit of this week when also having any free moments. So I try to do that. And Julia had a good point that I was not heating my things up enough. I wanted to make this little fossil from Animal Crossing because it's small. It felt like it was a reasonable goal to make work for metal casting and pewter. And so from there, I did get cast, but you can see the surface finish. And hold on, if I can focus this a little bit better. The surface on it is all pitted with holes. And Julia was pretty clear. They're like, oh, it's hardening as soon as it hits the silicone. So in order to cast metal like this, I need to preheat my silicone so that it's already hot. And she said I can just microwave it. I haven't been able to try it since she made that recommendation, but it's neat. And this little piece is almost a pound. Like it's amazingly dense stuff. It's like nonsense how dense pewter is. So if you want something to feel really heavy and official, you can do that. This is one that has, I think, a better surface finish. You can see it totally looks like a little fossil. But I didn't cast it all the way through. I was not fully invested in this one. So I just like poured a little bit of metal in and sloshed it around while the mold was still already hot from the last casting. And so it did have a better surface finish, but I wasn't able to recreate it a second time. but I've got pictures of these. Putting pictures like this for everybody is good to do in the foundation's Google album, right? It's foundation, so you can throw them in there. That's great to share so that Kate can have them for promotional things, and that we can show off all the cool stuff that the class is doing. So there's this sort of stuff that you can do. There's all sorts of things. Pewterware would be great. I would love to see the pewter stuff happen. And so there's all sorts of different things. Yeah, so it's neat to see sort of what's going. I really love that everybody's getting to explore their different ideas, different projects that they're looking into. And I love it when we push the whole game forward. Like it seems like there's probably not a whole lot of metal casting that's happened, but we're headed in the right direction. Ooh, good point. Kate, if you could share that link, you probably already saw that. Cool. We would and throw it in foundations, the foundations chat also if you can, so that it's there for everybody.